The last section in Unit 9 is titled Powers of Monomials. So today we're going to learn two more properties of exponents. Still working in the 8th grade standard. Again, we don't cover it in algebra, so we want to make sure that we get the basics covered here. So first to review, let's remember that when you are multiplying powers that have the same base, you're going to add the exponents. So for number 1, we get a to the 7th power. For number 2, we have c to the 9th divided by c to the 4th. When you are dividing powers with the same base, we subtract the exponents, so c to the 5th. Remember in number 1, this comes from a times 5 more of them. And when you add all those up, there are 7 a's. In number 2, similarly, there are 9 c's in the numerator and there are 4 in the denominator. So it's kind of like canceling out. And then when you don't have any more to cancel in the denominator, you're left with c to the 5th. So now there's a property called power to a power. And what this says is that to find a power raised to another power, we're going to multiply the exponents. So for example, we have a to the m power, and it's being raised to the n power. You're going to multiply m times n. In the examples here, we have 6 to the 7th being raised to the 9th, so that becomes 6 to the 63rd power. 7 times 9 is 63. And then 2 squared to the 4th power becomes 2 to the 8th. And I'll show you in this example why this works. So remember that 2 squared being raised to the 4th power means that there are 4 2 squareds. Well, 2 squared is 2 times 2. So all of the 2 squareds become 2 times 2. And now if you add up the 2's, there are 8 of them, so 2 to the 8th power. So let's simplify. 9 to the 6th raised to the 2nd power is 9 to the 12th. Q to the 4th raised to the 5th power is q to the 20th. 4 to the 3rd raised to the negative 7th is 4 to the negative 21st. But remember from our 9-4 lesson, we can't leave a negative exponent in an answer, so we need to move that power into the denominator in order to make the 21 positive. The answer on the right would be the accepted answer. The answer on the left would not be accepted. Now let's look at another rule. This is called the power of a product. So this is saying if you have a product being multiplied together, that's two or more things being multiplied together, that's raised to a power, it's going to equal the product of each factor raised to that power. Some students like to refer to this as the distributive property. It's not really the distributive property, but this is kind of what it looks like. If we have a times b being raised to the m power, that means we have a to the m power and we have b to the m power. So a to the m, b to the m. You can see why students kind of like to call this the distributive property. We just want to be careful with our terminology. You're not really distributing that power through the parentheses. So in the example, we have 2 times 4 to the 3rd power. That means that 2 gets the 3rd power and the 4 gets the 3rd power. 2 to the 3rd is 8, 4 to the 3rd is 64, 8 times 64 is 512. In the second example here, we have a variable, so this 4 is being squared and the x is being squared. Remember, this is 4 times x, that's a product, so the 4 gets squared and the x gets squared. So 4 squared is 16, x squared is x squared, so we get 16x squared. So let's look at a few examples. 5 r to the 7th, all being squared. So the 5 is getting squared and the r to the 7th is being squared. So we have 5 squared r to the 14th. Remember our earlier power to a power property stated we multiply the exponents, and 5 squared is 25. So we get 25 r to the 14th. Number 7, 2x to the 6th, y to the 3rd, all raised to the 4th power. So I kind of like to show that everything in there gets the 4th power. So it's 2 to the 4th, x to the 24th, we should be multiplying again, and y to the 12th. And you need to simplify 2 to the 4th. 2 times 2 is 4, times 2 is 8, times 2 is 16. So it becomes 16x to the 24th, y to the 12th. Number 8, negative 4s to the 5th, t to the 7th. So we have negative 4 to the 3rd power, and some of you can do this. Some of you can just do this right away. So negative 4 times negative 4 is 16, and 16 times negative 4 is negative 64. Then we have s to the 15th, t to the 21st. So recognize this negative 64. One common mistake is that students will say negative 12, s to the 15th, t to the 21st. This negative 12 is coming from 4 times, oh, whoops. I don't want to do that. This negative 12 is coming from the negative 4 times 3. But I want you to recognize why that's not correct. It's not negative 4 times 3, it's negative 4 to the 3rd power. So that's not correct. And in class, we will work on worksheet 9-6.